Okay, in this next example, we are given three sticks, lengths 19, 23, and 27 inches. We form a triangle with them for some reason and want to find the angle between 19 and 23. So to do that, you want to choose a tool to use, law of sines or law of cosines, because it's an oblique triangle. So in this case, I know all three sides. So this is a case where it's like side, side, side. But you can also think of it as, can I use law of sines by having a matching pair of an angle and a side opposite it? Because I don't have any angles, I obviously cannot use law of sines. So law of cosines is written here. Notice again, I've got A, B, and C, and I've got no labels for my triangle here, but I don't need them, it's okay. The only thing you have to know is the C, like I said in the previous video, they're kind of like the bookends. The angle here matches the side here. The side I want to find, I called theta. You can call whatever you want, but that's the angle I want to find, so that definitely has to be in my equation, cosine of theta. Now the rest of it, though, all I have to do is determine which one's C and what A and B are. C, again, has to be matching that angle, so C has to be 27. So setting up my whole equation, it's 27 squared equals 19 and 23, it doesn't matter which is which, so I'm just going to put them in this order. See if I can fit. Good enough. Okay, the one big difference here, law of cosines, when you're solving for an angle, see how the angle's buried here and all of this other stuff on the right side. So I need to work this out step by step. When the variable was here, as the side length, you could just type that all in at once, but I can't type in with the variable there. So piece by piece, order of operations, think of PEMDAS. The first thing I have to do here is exponents. So I'm gonna square everything. 729 equals 361, 529. I'm also gonna multiply, because these three terms right here are being multiplied together. 2 times 19 times 23 it was, gets me 874 times cosine of theta. Here's where a lot of people get tripped up. I cannot add these three numbers together. A lot of people want to do that because you see three in a row. This together is one term that you cannot break apart by adding and subtracting. It's a number times a variable. So I would need to break that apart by dividing. So my next step is leaving that as is, and I actually want to combine these two only, okay? So adding those two together, I still have 729 equals, it's 890 minus 874 cosine of theta. Again, don't touch this. This is a variable. This is like 5x. It's a coefficient with a variable, so I would need to divide to get that number out of that. So my next step then is not to combine those two 800 terms. I want to subtract 890 over. When I subtract 890 over, I get negative 161 equals negative 874 cosine of theta. And I'm worried because I got big numbers that are negative, and that's okay. That's fine. Now, like I said, to get rid of that negative 874, I want to divide by negative 874. Okay, when I do that, it cancels on the right side and leaves me just with cosine of theta. On the left side, I can type that in and get a decimal of like 0.184, but I'm going to leave it as a fraction. Fractions are exact. Because it's a negative over a negative, it becomes positive. Notice it's okay if that stays as a negative number, that's fine. And now I've got cosine of theta is that, okay? So to solve that, I want to do cosine inverse. Cosine inverse of that fraction exactly gets me 79.385. Degrees. One last thing I want to show you. Rounding error is something that can come up pretty frequently in here. So that's why I used a fraction here. If I instead did 161 divided by 874 and realized, oh, 3 decimals is pretty exact, so I'm going to use that instead. While I'm not extremely far off, notice the difference though between 79.385 versus 397. It is different, and we want to avoid rounding error whenever we can. So our best way of doing that is using exact numbers, which is a fraction, to get you your exact answer. Good job.